problem number 6. Let's look at the specification first. So this problem here, it's a little bit different from what we solved before, in the sense that the computational result does not depend on the contents of the input array. Rather, it depends on the so-called geometrical shape of the two-dimensional array. So the contents over here does not really impact the result that we have to return. Let's read the problem together and I'll make some more remarks. So given an input to the array of integers, so here the types of the contents does not really matter. So it could be integer, it can be string, can be person, can be facility, can be anything. Okay, so the shape of the input array is really what matters, not its contents. Determine if it is a rectangle. So we know rectangle, geometrically speaking, is something like this, right? This will be a rectangle. So we got a width, we got a length, and also the width and length are not necessarily equally long. In the special case where they are equally long, we call it a square, which we'll actually give you as an exercise later at the end of the video. Okay, each row, let's now define what a rectangle is in the context of two-dimensional array. Each row has the same number of columns. So let's take a look. Let's say for this particular input number 1, you can see we got 3 rows over here. The number of rows is not really the major factor to consider. It's really about the number of columns in the second dimension. You can see the first array in the second dimension, we got 1, 2, 3, 4. The second array, we also got 1, 2, 3, 4. In the third array, we also got 1, 2, 3, 4. So you can see the length has been consistent. Right? So now you can imagine how you will implement this as the utility method. You can think about it. I think that's already good visual hints for you. What about this second input array? Why would it not be considered as a rectangle? It's because you can see for the very first array, we got length 4. However, the second array over here, we do not have a matching length. In this case, it will be 3. So if you think about it geometrically, it's basically like something like this. So it's not really a rectangle, is it? Right? So that's kind of the problem we want to solve. We want to return a Boolean. It will be true for input like this. So it will be a rectangle. Otherwise, you're going to return false for input like this. All right? As usual, let's now document exactly what we want to achieve by declaring the method header and also the JUnit test, and then we're gonna code it up by by implementing how to achieve it. Let's still follow this standard workflow to make sure it's reinforce your understanding. All right, let's now switch to Eclipse. First of all, let's declare the method header. Let's now go to utilities. Okay, let's now go all the way to the end to our solution so far. Okay, let's now declare a new method. Let's say public and then static, and we want to determine something, so it will be a Boolean. And by the way, you can think about this problem here in some way is more like a universal property checking, because let's say once we know the very first row in the second dimension has certain length, let's say n, and then we want to say universally all the remaining rows in the second dimension must have the same length. So you can see it can certainly be reduced into a universal property checking problem. So that's definitely something you are familiar with, right? So it's not really a challenging problem, but you have to understand what we are really checking. So it's more like a geometrical problem, but it can be reduced to something that you're familiar with. All right, let's go back. Okay, it's going to be a Boolean return type, either true or false. And then how about we simply say is rectangle. Okay, a very rectangle. And then input is going to be the same type as always, integer. Oh, sorry. So it's going to be integer, two-dimensional array, A over here. And by default, we'll simply return false, just for now. Okay. All right, so that's about a header for the method. Let's now document what has to be achieved by writing some test case. Go to test utilities over here and go all the way to the end. So what we need will be test number 8. Okay, for now, I'm just going to copy test number 7, right? The contents, as I said, does not really impact the computational result, so I can keep the same value. I'll just adjust the shape if necessary. Okay, so I'm gonna paste over here. Let me maximize the tab, and then let's say number 8 over here. So input number 1. So what we really want is a 3x4, right? You can see the first one, the green one. We want a 3x4 rectangle. That's what we want. So if you want a 3x4, so you can see we got 1, 2, and 3, 3 rows, and then how many columns do we have for each? 1, 2, 3, 4, 1, 2, 3, 4, and also 1, 2, 3, 4. So it's a perfect rectangle. Okay, and then output number 1 and also input number 1. That's good. We just have to make sure we call the right method is rectangle, and then we're going to take input 1. Right, that's the only thing. And then the Boolean value should be true. Okay, so far so good. And then we got another one here. So this will be the second one. So we want to have 4, 3, and 4. Let's say just to match the paper specification. So we want to have 4, and then let me just put in a little bit more value here. 23, maybe 46, and then so here I can even put minus 100. Okay, so now we got 3 rows. And for the first row, we got 1, 2, 3, 4. And for the second row, we got 1, 2, 3. And for the third row, we got 1, 2, 3, 4, right? It's not exactly a rectangle. So what do we expect to see? First of all, let's now copy the method being invoked is rectangle. And we are expecting to see false over here. And then, so that'll be the expected result. Okay. You may just want to try another extra input. I will leave that as a simple exercise for you. You can just introduce another third input. Rather than being a rectangle over here, why don't you try a special case where you can just introduce another row over here, and that one there also got 1, 2, 3, 4. So this will be a perfect square. And the square is definitely also a rectangle for sure, right? But not vice versa. That's something we'll see when I give you the exercise at the end of the video. All right. All right, let's now go back here. And so that will be the test case we want to pass. And let's now go back to utilities. Let's now code it up. So what should we do? As I said before, let me just give you a little bit more explicit hints about what you should do. Of course, the assumption is we assume that the array that we are given as input is not empty. So you got at least one row. So if the input is only a single row, it will be a rectangle by default, right? But you can definitely have more remaining rows if necessary. So I would suggest the following. So this is how you can think of it. You should really calculate, first of all, the length over here of the first row. It's easy to get, right? You can simply say, what would that be? That would just be A0 will be the first row, and then dot length. Let's now, first of all, calculate this particular row by calculating its length, and then so that we'll get a number of columns in that. And then for the remaining rows, we just want to, for the remaining rows, let's now use a different color here. So for the remaining rows, so in this case, we got 2 remaining rows over here. For the remaining rows, let me maybe possibly change the color so you don't really get confused with the pink that's actually underneath. So why don't I put, how about purple over here, right? So for the remaining rows, you want to make sure they actually match, right? They should really match. Of course, when I say remaining rows, it really depends on the input. So you might just need a loop for checking the remaining rows. They should really match. Their length should really match. For example, 1, 2, 3, 4 should really match 1, 2, 3, 4. And also 1, 2, 3, 4 should really match 1, 2, 3, 4, and etc. So that'll be the hints for you. All right, let's now try that. It's conceptually, once you really clarify the doubts, and it's actually quite easy to implement. Let's now do it quickly and then pass the test. And then I'll give you some exercise. And you will do something similar for the second input as well, right? Once you fix the, once you actually inquire about the length of the first row, and then you can use that to check against all the remaining rows. The same process. Let's now go back to here. So why don't we do the following? So we can say integer, let's say number of columns. So that would be basically it's about the for the first row, right? Will be A0 will be the first row dot length. And let's document also quickly the assumption. The input array is not empty. And a special case would be a single row input is also considered as a rectangle. All right. So once we get a number of columns, we want to make sure all the remaining rows should really match, right? So now how do we check for all the remaining rows? And the question is, do we really need a nested loop? The answer is we don't really need, because for every row that we are looking at over here, we don't really have to go over the contents by contents. If we had to, then we would have to have an inner loop. But in this case, all we need to do is to, once you get reference to the start of this particular array in the second dimension, all you need to check would be what's its length. In which case, you can simply say, for example, a index 1 dot length, without having to write an inner loop to really go over the contents one by one, right? So we don't really need a nested loop in this case, right? Just to let you know. So the solution actually might be easier than you thought, but conceptually you should really know why. Let's go back here. So we'll say for all the remaining rows, so now integer r is initialized to be not 0 anymore, it should be 1. If you initialize that to be 0, it's okay, but just redundant. Okay, so let's say would be 1. R less than a dot length, right? R plus plus. And since we are almost like doing a universal property checking, so let's now, again, it's not really recommended for you to use any break statement. As I said before, the break statement is actually considered as a poor practice for resulting in code that's unnecessarily complicated for tracing. So for better code structure, use a Boolean variable to really control the exit of your loop. So I would say Boolean over here, and then I would say all remaining, let me give it a little bit long name, but it's kind of up to you. You want to have your Boolean variable to be named as informative as possible. All remaining rows equally long. All right, I can say true in the beginning, right? Since we are checking the universal property, and then we're gonna have some early exit, meaning that as soon as we find a row whose length does not match the standard, the criterion over here, that means it's time to exit, right? We can really implement this more optimized version. So to really do that early exit, I can simply put this state condition over here and say that, right? So now we want to say we will stay in the loop if the conjunction is actually true. We'll stay in the loop either it's because we haven't found any remaining row whose length is does not match the criterion length over here. And also we want to stay in the loop if the R is actually a valid index for the row, right? If any one of them is actually false. For example, if this happens to be false, that means we have found the so-called violation witness. In that case, it will be time to exit, right? It's a quick review. Okay, so here, how do we update the Boolean variable? We can say that one simply reassigned to a at index r dot length over here equals the criterion length. That would be the first row, right? You can see here. All right, and that'll be it. And then we want to say eventually we just want to return this particular Boolean variable. Let me just copy its name over here. Let's copy that. Okay, either true or false. All right, hopefully that makes sense to you. I think in some way, as I said, solution does not seem to be complicated, but you have to understand what we are doing over here. It's really important. So that's why visualizing it will be quite important here. All right, let's now run the JUnit test over here. And we got a green bar. All right, so now it is working, and you can review the details for this solution if necessary before you actually do the exercise which I'm about to assign to you. So what would be the exercise I want you to do? Okay, a very similar problem would be something like this. Okay, it would be problem number 7, but I'll just give that to you as part of problem number 6. Let's read it together. Given an input 2D array of integers, but now again, so whether or not it's really storing integers is not really the point. The point is about its geometrical shape. Determine if it is a square. So now what would be the definition for a square? Each row has the same number of columns. You can see this part over here is the criterion for rectangle, right? Just this part alone. So this is about what it means to be a rectangle. And furthermore, there will be some special criteria we have to we have to satisfy in addition, and that number is equal to the number of rows in the 2D array. So this part is really what makes it a square. Let's now take a look at one example here. Okay, so now if you look at, let's say for this particular one, this input number 1, is it a square? It is. You can see not only that, you can see once we get the length of the very first array, the length is simply 4. And then we want to make sure every array, every remaining array in the second dimension will also have the matching length 4, which is the case. However, this is only how we check it if it's actually rectangle. We also need to make sure this particular length over here also match the number of elements in the second dimension. So it's also important for you to see this part over here should also have a matching length over here. So this part over here is also 4. Right? You can see there are actually more conditions that you have to check. So in this case, it would be a rectangle. What about the second input over here? I'm giving you to try. Let's see the second one over here. You can see this part we got 4. You can see this part here we got 4 elements, and then this first remaining row also got 4. Second remaining row also got 4. So far so good. It's definitely a triangle. However, is it a square at the same time? It turns out it is not, because if you look at that, this particular the number of rows over here, a.length, will just be 3, and you can see that 3 does not match 4. So this is not a square. So in terms of the expected result, so we should really expect to see false for this input over here, and we should really expect to see true for this input over here. All right, so this will be an exercise for you. Okay, so this will be exercise. And what you should do is try to follow the normal workflow we have recommended. Write a JUnit test to document what should be achieved, and code up the method and try to achieve it. And I think the solution will be somehow very similar to what we did previously for this one. It's more like with some extension to make sure you can also match the number of rows in the first dimension. All right, so that's about these two problems over here. And let's now move on to the last problem for this week.